Today we're going to be taking notes on conditional statements and proofs. This is a recommended possibility of how your notes might look. For sure you're going to have your title here. We're going to be discussing some definitions and then some things that we know about angles, and my guess is that that might take up one page. It could be more, it could be less. On the back of your page you might be able to organize your work into two sections here. It's possible your notes might exceed this, but this is kind of recommended so that you know what your notes might look like at the end of this video. So what is a conditional statement? A conditional statement, it's symbolized by P arrow Q. This means, right here, it means if P then Q. So a conditional statement symbolized as P then Q is an if-then statement where P, this part, is the hypothesis and Q is the conclusion. Let's see if we can identify the hypothesis and conclusion in a few examples. So for example 1, if a polygon has 3 sides, then it is a triangle. So this is already a conditional statement. I can see the if, I can see the then. I know that the event after if is going to be the hypothesis. So I'm going to go ahead and record that. A polygon having 3 sides is the hypothesis, and we can go ahead and write in hypothesis. Then it is a triangle. The second event is the conclusion. What this means is if this is occurring, then this will happen. So this is the result of this being set up as set up. Okay, here's our next example. My car does not turn on if it doesn't have gas. Now this is a conditional statement, even though it's not written in the typical if-then format. So sometimes we rearrange the sentence to kind of confuse you a little. So you have to ask yourself, what's the setup and what's the result? So when I look through here, it says my car does not turn on if it doesn't have gas. Now I know that if my car doesn't have gas, then it won't turn on. So this is the setup, this is the conclusion. That means that this is the hypothesis, and this is the conclusion. Okay, and those are conditional statements. Now in geometry, what we do is we use a set of conditional statements or a set of truths, and we organize them to prove a point. So down here what I have is a set of conditional statements. You can see the ifs, see them all in the row, and a bunch of thens. Okay, what we're going to do is we're going to organize all of these conditional statements so that we can prove a point. Let me give you an example of what I mean. Let's say I have this one conditional statement, and that conclusion happens to be the hypothesis of the next one. And the conclusion of that one is the hypothesis of the next. And we just keep on going until we get to a point. What I mean is that what we're going to prove is that if I have this setup, the if from the A statement, the A conditional statement, then I can use my logic to get to the conclusion of E. Now don't worry, you don't have to copy this whole thing down. What I want you to do for this exercise is copy this title, this diagram, and then I want you to pause the video after you've read 1, 2, 3, 4, 5, 6 conditional statements. I want you to take a moment and organize them so that they make sense. So see if you can figure out what the beginning hypothesis is and connect all of these conditional statements to get to the last conditional statement. All right, good luck. Unpause the video when you're ready to see the actual answer. Okay, so you should have put them in order. Let's see how you did. Okay, the first one, the first statement is, if it is raining, then I will bring an umbrella. Then, if I'm carrying an umbrella, then I will lose it by block 1. If I've lost something by block 1, then I'm going to find it block 3. If I find something lost by block 3, then I will be happy. If I'm happy, then I will enjoy doing my homework. If I enjoy doing my homework, then I will get an A. Okay, as you can see, all of these statements kind of fit together like a puzzle. And in the end, kind of strangely, here's what we really proved. We really proved that if it's raining, excuse my handwriting here, then what? I will get an A. And we prove that really by connecting one conditional statement logically to the last one. And that's how we use conditional statements to prove a point. Okay, so now what we're going to do is we're going to transition, now that we know what conditional statements are, and we're going to write up all of the conditional statements that we know about angles. These are the facts about angles. So if I see this, then I know that. So the very first one you learned about this year has to do with vertical angles, and it goes something like this. If two angles are vertical, if two angles are vertical, if two angles are vertical, then they are congruent. And you can draw a little picture. That means these two angles right here are congruent. Okay, that's one conditional statement we know about angles. Here's another. If angles form a linear pair, if angles form a linear pair, then they are supplementary. Supplementary. Okay, and then we'll draw a little picture right there. So there's a linear pair. So we could say angle 1 and angle 2, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. That linear pair is supplementary. Okay, there's one last one we're going to put in, and it has to do with the angles in a triangle. You know this one probably from 7th grade. If a shape is a triangle, then its interior angles are supplementary. Okay. So if a shape is a triangle, then its interior angles are supplementary. So that might look something like this. So you have a triangle with angles 1, 2, and 3. And I know the measure of angle 1 plus the measure of angle 2, 2 plus the measure of angle 3 equals 180 degrees. Okay, now we're going to pause for a second. We're going to do some thinking, and then we're going to add to this list. Now, before you freak out, you do not have to copy this down. I know you got scared there for a second, but don't just take it easy there. Okay, what you're looking at is a construction. Okay, so this is from a computer software program called GeoGebra, and it records everything that I did. And over here, these are the constructions I did, and it doesn't look like the constructions you did because you only put in the arcs. But I want you to think about this: when you do an arc, you're just making a piece of a circle. So that's what you're looking at here. Now, if you take a look at it for a second, you can see that what I did is I actually started off with an existing line. So I started off with this line right here. And then I gave myself this point C that's right here. Okay, so I had a line and a point, and what I did is I constructed a second line, this line, that was parallel to the existing line. So this is exactly the construction that you did 3 times already. What I wanted to do is I want you to think about kind of what this construction means. Okay, so what you did is you created an arc, and then you replicated that arc here. And then you measured the size of this arc, and you replicated it here. and then you connected those two intersection points to make a parallel line to this line here. What you're really doing when you do this construction is you're figuring out what this angle is here, and you're copying it here. If you're copying an angle, then you're creating a congruent angle. That means that you knew what this angle was, and you copied it here. That means that those two angles are congruent. Okay, now you also know, because of linear pairs, that, do you see this line right here? This transversal? That means that this angle right here, it adds up with this red one to add up to 180. Well, that must also mean that this angle right here also adds to 180 with this one. That must mean that this angle and this angle are congruent. That makes sense because I know that these two angles are congruent, and if this one is supplementary to this angle, well then they're supplementary to the same angle. Therefore, these angles must be congruent. Now if I use that logic, I can go all the way around. That means that these two angles must be congruent, and that means that these two angles must be congruent. Do you recognize those pairs of angles? Those are corresponding angles. Corresponding angles are congruent. And what I wanted to point out here, and I hope you see this, is that really this intersection right here, when you copy this angle to create a parallel line, you're really creating an identical set of angles. These four angles are exactly the same as these four angles. Now it gets more interesting. You're like, wow, how could this get more interesting? It really does. Now I want you to think about what we know about vertical angles. Vertical angles are congruent, right? So that means that this red angle right here and this red angle right here, what's vertical? This angle. So really, these two angles are the same. That means I've got four angles that are all the same. And you know what? These two are the same measurement too. So now we've even gone deeper here. Think about this. This intersection right here has really two distinct angles, whatever these red angles are and whatever these blue angles are. And when I do my construction, I'm copying this intersection above it. It's an equal distance all the way around, but no matter how wide I make this distance or how narrow, this intersection creates the same 4 points. The same four angles. So let's kind of keep this in mind as we create our last three conditional statements about parallel lines. Okay? So continuing with our list, let's kind of reflect on what we just looked at and add in some new conditional statements. So here's our first one. If two parallel lines are cut by a transversal, that means if you have the situation that we just looked at, if you have two parallel lines cut by a transversal, then I know that the corresponding angles are congruent. Corresponding angles are congruent. Those are those four angles that are all the same. Then the four corresponding angles are congruent. Okay, here's another one. And this is kind of inherent from after we realized that it was just the same two angles. If two parallel lines, I'm going to move this one out of the way. If two parallel lines are cut by a transversal, then I also know that the alternate interior angles are congruent. Alternate interior angles are congruent. And the last one has to do with those consecutive angles. Other people call them same side interior angles. It's the same thing. I'm going to go ahead and write them as same side interior. Then the same side interior angles are supplementary. And again, just to make sure you know what I'm talking about here, same side interior angles are consecutive interior angles. So you may want to write that in.